So today we're going to talk about lesson 59, which is rearranging before substitution. I'm also going to go over substitution in general a little bit because I haven't been there to teach a lesson for it. So I just want to make sure that we completely understand what substitution is before I jump into the rearranging part. So these two examples are like the ones in our textbook that we've done so far. We have two equations that both have the same values for x and y, and one of them is already set equal. So the second equation here already tells us what x is. So all we have to do is take what x is and plug that in for x in the first equation. So let me do that one for you. If I take the whole value of x, which is 2y plus 3, and plug that into the first equation, I'm able to solve for y. So if you look here, I plugged in my value for x, right where it used to be up there. And now the only variables I have left are y's, so I can solve for y. I'm going to have to do some distributive property here. So that would be 2 times 2y and then 2 times 3, which makes it 4y plus 6 plus 3y equals 5. Now I'm going to keep going. I'll take these terms on the left side of my equals sign and I can put them together. So that will be 7y plus 6 equals 5. Now I have to get rid of that 6, so I'm just going to subtract 6. Over here, 5 minus 6 is just negative 1. On the other side, I still have a 7y. Then to get rid of that 7, I just divide by 7. So I should get the answer of y equals negative 1 over 7. I know my y now, but I don't know my x yet. I'm going to have to take this y value and plug it back into either one of the equations. It doesn't matter which one I plug it into, so that I can solve for x. So let me take the second equation. So I have x equals 2y plus 3. That was my equation right here. And I'm going to plug in this y value to solve for x. So I have x equals 2 times negative 1/7 plus 3, which is x equals negative 2/7 plus 3, and I'm going to have to make a common denominator here. So let's make that 21 over 7, which would make x equal 19/7. And those would be my two values, and I could write that as an ordered pair and make that 19/7 comma negative 1/7. And that would be my final answer. Okay, let's try another example like this. In this one, they tell us what y equals. They say that it is x plus 4. So I'm going to plug in the whole value of y for this y in the second equation here. So that would make the second equation 2x minus that whole thing, x plus 4, in parentheses because it's that whole thing, equals 7. And now all I have to do is solve. And it's important that we put the parentheses there because now we have distributive property. I have to distribute that negative. And if I distribute that negative, all that's doing is changing the signs of all the things inside the parentheses. So it'll make it 2x minus x minus 4. Because it was originally a positive x plus 4. Now it's negative x minus 4 equals 7. Now all I have to do is solve left to right. 2x minus x is just x minus 4 equals 7. Add that 4 on both sides. Makes it x equals 11. So now I know my x, but now I need to know my y. So I'm going to take this value of x and plug it back into my original equation to solve for y. I would pick this one here because it's the easiest. The y is already isolated on the left, so it'll be really easy to figure out what the y value is. So if I take that x value and I plug it into my equation, I have y equals 11 plus 4, which is just 15. So I know my two values, and I can write that as an ordered pair, which would be 11, 15, and that would be my final answer. Okay, so now that we've looked at some substitution problems where they already had isolated one of the variables, now let's look at one where they didn't isolate. So like this one here, we have two equations and neither one of them has an isolated variable. The first one has the x and the y both on the left side of the equal sign. The second one does too. So we have two decisions to make. Our first decision is, do we want to use equation 1 or 2? Or in this case, equation A or B. And after we decide which one we want to do, we also have to decide whether we want to solve for x or y. And there's no right or wrong answer. You can choose either equation first, and you can choose to solve for x first, or you can choose to solve for y first. It doesn't matter which one you choose. It's totally up to you. But I suggest you look for the thing that'll be the easiest to solve for. So right off the bat, looking at both of these equations here, this y has a 2 attached to it. So I'm going to have to do division to get that alone. This x has a 2 attached. I'm going to have to do division. I don't want to have to do division. This one has a 3 attached. These are all hard to solve for. The easiest one to solve for would be this x that's alone. It doesn't have anything multiplied by the x, so it'll be the simplest to solve for. All we'll have to do is do some addition and subtraction, moving things around. So I'm going to choose to solve for this x first. So let me rewrite my equation. X minus 2y equals -1, and I'm going to solve for x. In order to solve for x, I have to add that 2y to get rid of it on this side and add it over here. So I have x equals -1 plus 2y, and that's it. I already solved for it. See, it was really easy. All I had to do was add one thing. So this is my x value. And now I'm going to take that x value and plug it in to the other equation. Right here. So let me rewrite that. I have 2 times my whole x value, -1 plus 2y, minus 3y equals 4. Now this sets me up for some distributive property here. So that'll become -2 plus 4y minus 3y equals 4. Let me keep solving. I can put these together. I've got some like terms on the left side. So then I have -2. 4y minus 3y is just 1y, or y, equals 4. Let me add that 2 over here to get rid of it. Add it over here. So I have y equals 6. Okay, so I solved for my y, but I need to know my x still. So I'm going to take that y and I'm going to plug it right in over here, because this equation is already set up to tell us the value of x. X is already isolated, so it'll be the easiest one to plug in. So I'll plug in the 6 as my y, so it'll be x equals -1 plus 2 times 6, because that was my y value. So x equals -1 plus 12, and -1 plus 12 is just a positive 11. So now I know my x and my y, and my ordered pair would be 11, 6, and that is my answer. Okay, let's look at this example. We have two equations here, and I have to decide which one I want to look at first and which variable I want to solve for first. Looking at these equations, the one that looks the easiest to solve for is probably this y right here, so let's solve for that. I'm going to rewrite this equation, and now I'm going to try to solve it for y. So I want that y to stay on the left. I need to get rid of that 2x that's over here, because it's in my way. And whatever I do to the left, I do to the right. So I'm left with -y equals 10 minus 2x. Now I only have one thing in the way of that y, and it's that negative. So the easiest fix would just be to switch every single sign. I'll make that one positive, negative, positive, and that's it. So I have y equals -10 plus 2x. And now that I have my y alone, I can take this whole value for y and plug it into the other equation. So I'm gonna write 4x minus 3 times that whole value for y equals 16. Okay, now we just have to solve. And I see some distributive property is gonna happen right here. But I'm gonna go left to right. So I have 4x minus, okay, let's see, negative 3 times negative 10 is positive 30. Negative 3 times 2x is negative 6x equals 16. Let's keep solving. I see some like terms. So 4x minus 6x would make that negative 2x plus 30 equals 16. Okay, let's keep getting rid of things that are in the way of my x. Let's get rid of that 30. And get rid of it over there too. So we have negative 2x equals 16 minus 30, which should be negative 14. And then just have to divide by the negative 2 on both sides, which will make x equal positive 7, because it was a negative divided by a negative. Okay, now that I know my x, I have to solve for my y. So I'm going to take that and plug it right back into this equation that I had already set equal to y. So this will become y equals negative 10 plus 2 times my value for x, which was 7. So y equals negative 10 plus 14, or y equals 4. Now that I have my values for y and x, I can write my ordered pair, which would just be 7, 4. And that is my final answer. Okay, example 3. We have these two equations. My first step is to figure out what I want to solve for. Again, they left us with a variable that's alone. It's the easiest one to solve for. It would be that y there, because it doesn't have any other number attached to it. So let's start off by solving for that y. So we have 2x plus y equals 25, and I want to get that y alone. So let me subtract the 2x that's in my way over here, and subtract it from here. So then I have y equals 25 minus 2x, and we're already done. We solved for it. This is our whole value of y, and it's going to get plugged into the other equation right there. We have 4x minus 2 times the whole value, which was 25 minus 2x, equals 38. And again, we get set up for some distributive property. So we will have 4x. Negative 2 times 25 would be negative 50. Negative 2 times negative 2x is a positive 4x equals 38. We have some like terms over here. 4x plus 4x is 8x minus 50 equals 38. Now I have to get rid of this 50. That'll make it 8x equals 88. My last step is to divide by 8 on both sides, and then I get x equals 11. So now I know my x, but I'm not done. I have to plug that in to solve for y, and I'm going to plug it in right here. So y equals 25 minus 2 times 11, because that's my value for x. So y equals 25 minus 22, or y equals 3. Now I know my x and my y, which means I have an ordered pair, which would be 11, 3. And there we go.